Hi everyone. Let me quickly walk you through the journey to Agentic landscape using MuleSoft. As many of you have been asking me, how do I start? Where do I start? So let's have a quick walkthrough. So basically we have 5 steps to become or deploy a agentic landscape. And to get there, you have to start with your APIs, your microservices, your architecture you have in place, and decide what are the component systems and data you want to make agent ready and available to the agents. So you start thinking about exposing these assets as MCP services. This is the first step we are going to look at, where we are going to convert the existing Mule API into a MCP server. Second, once this is done, you can govern and secure the MCP service. Here, applying policies is important, making sure not that agents have to authorize in order to use those tools. This is something you can do then with the govern and secure part. Then you are already agent ready, or your architecture is agent ready because you have exposed and secured MCP tooling through MuleSoft. Next step would be to build agents, and that's something you can do anywhere. You can use Agentforce, you can use custom third-party products, you can use MuleSoft or Heroku to implement agent or agentic workflows. And then once you have done it, make sure these agents are speaking the A to A language. So make them A to A conform. That's something which is happening here in the third step. And in the fourth step, you have to do the same what you have done to the MCP services. Make sure your agents are governed and secured. So we apply policies here. And finally, all those assets are available in a internal agent portal where everyone in your organization can discover these assets and decide when to use a certain asset like a MCP server, or even subscribe to an agent in order to use it in their specific projects. That's something where we are going to look at. So let's start with the very first one, which is exposing MCP services. And in order to expose MCP services, we are going to look at the MCP support of MuleSoft. Let's take a look how it is presented in MuleSoft. So this is an API specification I've implemented using the MuleSoft best practices. Means there is a API specification design which I implemented. So everything is scaffolded, as you can see here, and I have 3 endpoints currently. And if I go to Postman and hit the request button, you can see this API is operational. I am on the local host, I've deployed it locally, so I can interact with this API, which has 3 endpoints. Now, in order to make it agent ready, I need to decide what are the endpoints I want to expose. I would probably expose all 3. And the first thing what I need to do is I need to add the MCP server, or the MCP support into my project. And there we have an MCP connector available. You can drag and drop it into your Mule palette, and then this should be available. And once it's available, you can see it has different resources and operations. There are implementation or operations which are affecting the client side, and there are operations serving the server side. And we want to use these endpoints and convert them into MCP tooling. So this is the operation we would need to use. Let's drag and drop it here. And I will now add the configuration part where I'm going to reuse basically the HTTP listener which was provided. Make sure to use a streamable HTTP server, which is the latest supported version of MCP protocol. Let me just type in the name. This is MCP server 1.0.0. That's about the configuration part. And now I need to describe basically what the tool is. So here I'm talking about get inventory. So that would be the name of my tool, get inventory. And now I need to add some semantics to the get inventory tool because the agent is going to use it. So I need to provide here a clear description in plain English. I've already prepared this. So this is an inventory tool when you should be using it, how to use it as a material number, as a param value you have to provide. So just describe what this endpoint is doing and how you are handling it. And the next step is to provide a JSON schema or parameter schema in JSON format, which I've also prepared. So make sure that the input parameters are presented in the schema. And I will walk you quickly through my schema, what I have here. So you can see it's a JSON schema of type object. I have properties, which is the only property material number. I'm describing the material number and make it even required. And there are no additional properties, and that's it, right? So the same way you would consume it um, with the API, you will provide the same schema and description of the parameter through that parameter schema. And finally, we need to define the format for the response. Here you can just simply go payload raw, and I can say this is valid for an assistant, and the priority for this one is by default 1. That should be fine. And before I click on save, let me also show you that the local deployment shouldn't have any MCP yet, right? Because I didn't save it. So let's go and save it and see how it will deploy the application. So you can see it has started to deploy the application. So it's going now. It will do it. Just we wait a little. So everything is present. I just need to save it. So now it will redeploy the application, and we can now first of all take a look if the API is still working. Indeed, let me change the number of the material. Yes, so the API is working, and if I do the same with MCP, now I have one tool available, and if I run the tool with mule test, you can see this is exactly the same response I would receive if I would call the API. So this operation or this method is now converted. You can see also if I change the number, it's the same thing what I'm receiving. So I already deployed this API into my Anypoint runtime manager, where you can see this is basically the URL. If I copy it and paste it here, you can see I'm able to access all the three tools this time because I've converted all three. So there is a get inventory, submit order, and submit delivery. That's the way how you handle Mule APIs. There's another way if you are not managing or implementing APIs using MuleSoft, but you still have a lot of microservices and APIs in your ecosystem. How would you use it? So let me show you the other project where we used an external API to be converted. And this is a scheduling service which is deployed on Heroku. And this is the way you deal with it, right? So you drop a MCP listener on each resource which you would like to convert. And the resources you have to explicitly call out using the HTTP request of MuleSoft. And this is also pretty simple. You can see here exactly I'm calling that specific URL on Heroku, providing the payload, defining exactly everything in the right schema and order, describing also the tool itself, giving it a unique name. That's the way how you would expose external APIs. So now let's continue and see. The first step is then MCP services are exposed. Second, we need to now secure these MCP services and govern them. So let's go into our Anypoint platform and go to the first step where I have governed the MCP server for ERP, which I deployed. And this is my consumption URL or consumer URL. Let me call this out from Postman. Oh, I have it here already. So this is basically the URL which I prepared. If I call it out, you will see I have three tools, right? Currently, no headers are provided, no authorization. It's open for everyone. But I can go and say I would like to add authorization to it. So let's say I would like to at least have client ID enforcement on top of it. So I add this policy. By adding the inbound policies, you can see all the different MCP policies. And you can also leverage all other policies we are also providing as part of our API management solution. For MCP, we have dedicated one, but still you can leverage other policies like I'm doing here for client ID enforcement. And if I would like to connect now, it won't let me because it's failing on the authorization part this time. And here I would like to provide the authorization, but via SLAs. So I define two SLAs where I have a base subscription, just read-only access to one tool, and the advanced subscription is all tools provided, access to all tool providers, plus I have a generous amount of rate limiting, while as here I have a limited amount for the rate limit. So let's take a look how it would work. So the base subscription, by applying the policy, if I just go in, you can see it sees all the three tools, right? And that's not what I want. I want the base subscription to be limited to see only get inventory tool, and the advanced here should be able to see all the three tools. Yeah, so let's take a look what we have to do. And this time I need to activate the policy called attribute access based control. And now, while this is being activated, let me show you what you have to do. You have to provide CEDA expression and on the tool level itself, the tool call itself, and mention exactly the resource which should be available for a certain SLA ID. And this SLA ID is for the base subscription, and the other one is for the advanced subscription. And you can see that in the advanced subscription, I'm permitting all the three tools, while as in the base subscription, I'm only permitting one single tool. So let's take a look how it appears in Postman. We try, of course, first the base one. And now the base subscription only sees the get inventory tool, while as the advanced subscription would see all three. This is pretty cool because now I have produced the MCP server and I have governed and controlled it based on different SLAs I've defined. So my users who will be subscribing to a certain SLA will be getting a certain amount of service from that MCP server. But this is where I produced the MCP server, right? But you may have MCP servers available like the one from GitHub, where you can see I have in total, if I go natively to that GitHub MCP server, I have natively a lot of tools available, like in total 94 tools. And if I now go to, again, MuleSoft platform, where I have the GitHub server also governed. Let me show you. It's here really directing to the GitHub Copilot. I have a consumer endpoint generated, and I have three SLAs, like for developer agents, tester agents, and architect agents. And if I would go now through MuleSoft, for developer, I want to give full freedom, so they should have access to all tools here, at least not all the tools, but the large amount of tools. For architects, I want to limit it to 50 tools. Let's see how much they have. So 49 tools they have available. And for the tester agents, I would like to limit it even below 30. So this is how you can govern the MCP provided from external parties in MuleSoft, fully secure them, and provide access to the tools you want the people to access. Let's take a look. This was the governing part where we have used now policies after deploying the MCP services or even external MCP servers. Bring it into the MuleSoft Flex Gateway and apply the policies you need. Not only the ones which are dedicated to MCP, but you can also apply policies like client credentials, which we had in our API management offering already, and apply it to the same service for MCP now with the same approach and handle authorization, rate limiting, and anything else you want to handle and govern this MCP server, like we have seen with the attribute-based access control. Um, this is something you can easily implement with MuleSoft. So now you are almost agent ready, or your APIs which you have exposed and governed are agent ready. But how would you build agents, right? So the building part and supporting part for A2A is important. You can build agents anywhere. Yeah? We are providing also some connectors you can leverage to build agentic experiences in the MuleSoft app and govern them and provide with A2A support. So there are different connectors we are providing. First of all is the Agent Force connector, which can leverage the agents deployed in the Agent Force ecosystem, teleport it into MuleSoft, apply the A2A protocol on top of it, and then they are A2A ready. You can deploy it, or you can even implement your own workflows using vectors or inference connector, leverage the Amazon Bedrock agents, put A2A around it, and your agentic workflows are ready. Or you go a completely custom, do-it-yourself approach where you leverage maybe Python or LangChain and then implement these agents. And once you have done it, you can apply the MuleSoft A2A support on top of it to be leveraged and compliance to the A2A standard. So let's take a look how it would look like. And I will go here into my Visual Studio Code and run this agent, which I have here. It's a simple agent for, let me open it. So this is the Python agent I have here. Let me just run this operation. So the moment I run it, the agent is available. And let me go here to show you that this is a real agent I have created in Python using the OpenAI SDK. You can see it's responding. So this agent has been simply created here. You can see the code base. We are not going to dive into this one, but I took that agent and deployed it into Heroku. So I have an endpoint available from Heroku. You can see here, this is an app which is deployed on Heroku. I can ask the question, it will reply the same thing. So now this is my agent, which is having a prompt and giving me a reply. How can I make this A2A ready? This is where MuleSoft again comes into the game. And this time we are going to use another project where we are calling out to that agent. So you can leverage it and surround it with the A2A support. And let me show you what this means. So this agent workflow is starting with the task listener. The task listener is something the A2A connector is providing, and it is applying an endpoint conformant to the A2A protocol with all the fields, with all the structures it has, and it helps you to support also the response in the same format of A2A. We just need to set some default. The minimum things are prompt, session, and task ID. You have this here. Then you can do the call out to your Heroku service. In my case, you can see here, this is the Heroku service call out. And when I receive the response, I just format it in the A2A compliance structure, and that's it, right? And this agent I've deployed already in Cloud Hub. So in Cloud Hub, you can see this agent is available here. This is my agent. I can see in the dashboard. When I call out this agent, it should tell me exactly when the agent was called out. Let me call it out actually. So here you can see this is the agent which is deployed in Cloud Hub. I want to know what's the capital of Switzerland. I call out to that agent, and this agent is going to now reply to me. The initial step here is you can build agents anywhere. If you cannot make them compliant to A2A, you can use the A2A support of MuleSoft, surround it with a task listener, provide the default parameters of A2A, set them, call out the agent, and finally transform the output message according to the A2A protocol. And that's it. It's super simple and easy to deploy. We have deployed this agent, and you can see if I would refresh now, it should probably tell me that there was a call from outside, which I just did using Postman. So that's the step where we have now deployed, built the agent, and applied A2A support. Finally, we are going to now govern and secure the agent in the same manner. Let me show you in any point platform how you do it. So here we are in the same Flex Manager instance where I am on the A2A server. So I have already implemented the governance part. You can see I receive a consumer endpoint, which I will be using. And on the policy side, what I did, I activated rate limiting for now. Let's see how it is behaving. So when we go here, you can see this is the gateway endpoint. I'm asking a simple question. What does it mean if you apply a rate limiting policy? You can see we are exposing headers. So 3 are the rate limit, and 2 are available within this certain remaining time frame. I can hit again. Now it will reduce to 1. I still receive a response. I have 42 seconds. You can see this is the reply. Now if I continue and say one more, now 32 seconds is still a reply. And if I hit now, you see too many requests. This is where rate limiting is now fully applied on the A2A protocol, deployed agent directly from any point. You can also say, I don't want rate limiting. Instead, I would like to use the spike control, which is a better approach because you are not just failing the requests which are coming in, you are queuing it for a certain time period and still processing it. So I can now go and ask for the spike control, hit the limit with the spike control, and you can see I have just these 5 seconds where the rate limiting or spike control can be handled. So queues which are coming in within this 5 second will be, or requests which are coming in within these 5 seconds will be queued and still be replied to. So you can see it takes a little longer, but then you get a reply from any point based on the spike control policy. There's one more which I would like to show you is the A2A schema validation. So now let's see how it will apply, and you can see I'm missing the type part here in my request. So if I hit it, it will say that there is a validation error. It's not correct. So if I add here then the correct item, hit it again, it will reply basically back. So this is the A2A conform support where you say every request which comes in does the schema validation. We have also other policies like A2 API detector and few others you can leverage here, like overwriting the agent card, prompt decorator. Those policies are available. Plus all the other policies you know from the MuleSoft API management solution. Those can also be used for your A2A agents. So now let's take a quick look what we have done. Using the Flex gateway, we were able to protect not only our MCP servers, but also now our agents, apply policies based on our organization, control the agent access from any consumer, and even you can go beyond and provide the same SLA tiers offering you want to offer to your users when they are subscribing to these agents. This is what you can fully control along all the policies you have seen, not only the ones which are A2A specific, but also API management specific, like rate limiting, spike protection. These types of things you can implement easily using MuleSoft. And with that, you have governed and secured your A2A agents. So the final step is how you deploy and operate the agentic landscape. And as you know, we are going to release very soon Agent Fabric, which is uh, uh, derived from the concepts of the agent interaction layer, where you start with discovering agents from an agent registry. You can orchestrate based on the agent provided for a certain topics inside the fabric or the broker, we will call it. You govern your agents using policies, and you can even observe it using a visualizer. Let's see this in action, how and what we have as of today. And today we have already a strong foundation here, which you can see. Okay, this is exactly. So here you can see I have certain agents available here. We are even releasing here, you can see agents and tools beta. This is which shows you all the different MCP servers I have in my organization, along some out of the box MCP servers we are providing here for Wix. We have Webflow, CoinGecko. These are out of the box MCP servers MuleSoft will have, along the ones you have built for ERP and others like GitHub. Those are also available here. With the agents, of course, which are supporting A2A, you can see I have a Jira agent, I have a knowledge agent from Agentforce, HubSpot agent, again a knowledge agent or a account management agent from Agentforce, OpenAI agent, web search agent, and many more. So this is something you have, and if you want to use one of these assets, it's the same approach. Like you would go here to request control to the asset itself, describe the application you have. You can even create a new application. And the moment you have created it, let me say demo 1, it is available and you can request access. If there are no manual approval, you will receive the client ID and client secret. If there is a manual process, you will have to wait until someone approves it. Let me show you how a manual process would look like. So here I would access now this for this MCP server, ERP user, let's say here, create, and I can say I would like to have the advanced package. I request access, and now you can see this is what it says. The request has been received and is pending. So somebody need to go to that MCP server. Where is it? The ERP MCP server. Look into the contracts. See, here is a ERP user which came in. I can reject it, I can approve it. It's currently pending. The moment I approve it, the user can then leverage this part of MCP by going to its applications here in the portal. Click on the MCP user, and now you can see here are the client credentials and secret available. So that's what you can do using the portaling part of MuleSoft, which is becoming quite strong, as you can see here. But as we grow and continue, we have also additional things like, yeah, of course, the dashboards, capabilities on the agents itself, on the SLA sites, approval of users, so you can track your consumers. We have also the monitoring part for specific services agents which you would like to check regularly. Functional monitoring can be applied, so you can even experience maybe there is a MCP service not working anymore before user can experience it or agent can discover it. This is why functional monitoring exists for you to discover. You can set up alerts if needed. And in the insights, you can even see what's going on my agentic ecosystem. What are the different entities I've deployed? How many error did I face in the last couple of 7 days in this case? What's the error rate? You can drill down even on those A2A MCP services and see what is not so good, like the GitHub and ERP MCP server. The error rates are mainly because I've tested a lot of client credentials, authorization access. That's why it was declined. And that's also reflected here as well. So this is basically what MuleSoft is providing as of today for making you agent ready. And in order to get there, you have this agentic journey or the journey to the agentic landscape where you can govern basically anything. Start with the exposure of MCP services, either Mule APIs or any third-party APIs. Govern these MCP services which you have built and produced with MuleSoft, or you can even govern external MCP server as we have seen here with GitHub. You can build your agents anywhere, apply A2A support, Agentforce agents, third-party agents. Once you have done it, you can govern the A2A agents directly in MuleSoft, or if you have provided A2A support externally, you can also govern and register and onboard these agents to be available in the platform for other users. This is super important, so you don't hide the intellectual property you are building for your organization. It's available to a central repository so everyone is able to consume it. And then deploying and operating the agentic landscape, it's all about discovering these assets you have built and requesting access, using it, consuming it, and operating and monitoring it so you can guarantee that everything you build is future proof and secured, fully governed and controlled by your organization. So that's it, what I wanted to show. Hope it was helpful.